Okay, you're probably wondering, well, what's this assignment I got to do? Your assignment's a back page. I'm actually going to go over the first 2 pages for you. I would suggest you listen because now it's everything you've learned about this ordering and counting stuff thrown all together. Okay? First one's easy. A student council must have a representative from each class. There are 54 freshmen, 45 sophomores, 51 juniors, and 48 seniors. How many possible combinations of representatives could we have? Now, again, we're picking one from each group, okay? These are the easy problems, okay? I pick one freshman. Well, 54. Just because you see combinations doesn't mean you go to the C, okay? That makes no sense. How would you even set up a C on this problem, okay? The big C, I'm talking with the numbers to the side and underneath. Picking one freshman, 54. If I'm picking 2, it'd be another 54, but just one. Okay, 45, 51, and 48. You just can't overthink that. Okay, that's going to be a lot, but thankfully I don't need to come up with all. 5,948,640. This is used in probability. It's like if you randomly selected numbers out of a hat, what's the probability you could get this group? Well, I'd have to take, it'd be 1 out of that, so not a lot of possibilities. There are 5 people in a competition of pie eating. How many first through fifth? Okay, underline these words here. First through fifth, and you got 5, so that's the factorial. Okay, that's real simple. 5 by 4 by 3 by 2 by 1. The appropriate label for a factorial is complete orders. Boom. Now the next one, you got to be careful on getting these mixed up. People get them mixed up because they will not listen to what I have to say. There are 20 people in a spelling bee. Awards are given for first. Okay, I see these words. That's very important. How many first, second, third place finishes are possible? So you have 20 people, but you're not going first through 20th. Okay? So I need the big question. Start with the big question mark. Then we fill it in with either P or C. But first, let's arrange our values. We have 20. We want 3. 17 are irrelevant. I see those words. That means we're protecting it. And anytime I have to protect the first, second, third, or whatever that number is, we use the permutation. So keep the 3 out of the math. 20 factorial divided by 17 factorial. 20 times 19 times 18 times 17. And the 17s cancel. Permutations, I really don't end up using my division operation. I mean, it's there, but when I'm calculating it, no. Now, permutation, you're still putting orders, but it's not complete. It's just first through third. Or you can just put through third if you want, okay? Okay, there are 30 students in a class. 4 will be selected to take place in a survey. How many possible combinations of students in the survey? Okay, now we have, and you don't just divide, okay? That's how many groups you'd have if you grouped them, but I want to know all the possible groups. Totally different ball game then. Okay, so I obviously got 30. 4, there'd be 26 people that I'd pay attention to 4 at a time, 26 irrelevant. But I don't see these words here like I did in here. Well, no crap. That's because there's no first, second, third, fourth to it. You're not protecting it. That means you're going to the C. Okay? So a C, all these go in. Big number on top, 30, and then 26 and 4. Okay? So 30 times 29 times 28 times 27 times 26. Cancel those. And then the 4 times 3 times 2 times 1. Because, again, you're dividing. Because what happens when you divide a number? It becomes smaller. Well, with the combination and without having to take 4 and then re-rank them just with 4 people, You can get that out of there. So you small, shorten, or not really shorten it, but make it smaller. And then 4 times 3 times 2 times 1. Okay, 27,405. Now, order has nothing to do with this. It's combos of 4. Okay, card playing time. By the way, this is something you should have memorized without having to do the C. How many 5-card hands can be dealt from a standard deck of cards? 52 cards in the deck. Okay, 2,590,000. See, I don't even have it memorized. Tells you how smart I am. Okay, 598,960. So you don't have to keep recalculating that. Okay. How many possible ways can be dealt 5 face cards from a deck of cards? We have 12. So I just see one group. So I just need the C once. And you have 12 in the deck to pick from. You don't put 52 because all 52 cards don't have a face, someone's face on it. Okay? And we want to be dealt 5 of them. Okay? So 7 here. Card playing, we use C's. Okay? All the time. That's a dead giveaway. So nothing's protected. Calculate it. So 12 times 11 times 10 times 9 times 8 times 7. The 7s go bye-bye. 5, 4, 3, 2, 1. Let's get some parentheses where they go. Calculate how many combinations of 5 face cards I can be dealt. $792. Now, what's the probability of combos of, and since you have one C, you can see it's combos of 5. To find the probability that you'll be dealt Jack, King, 5 of these J, Q, K cards, Jack, Queen, King, you can divide by the 2,598,960. 0.03%. Okay, how many possible ways can I be dealt 5 of the same face card? There are 8. Get that out of there. That's if you're not a. I mean, I know how to figure it out, but if you're not a card player. Yeah. If you are a card player, maybe look at this, okay? If you're not, forward it ahead to me doing these. Don't stop it, but just fast forward when I turn the page. If you don't want to be confused, it's fine, okay? How many ways can I be dealt 5 of the same face card? There's 8 total of any face card because there's 4 face cards and 4 wild cards. So we're going to just use 1 C here because face cards is the one category. Okay, and I'm going to be dealt all face cards. Now, if 3 face cards, then you'd use 2 C's because you got the face cards and the cards that are not face cards. Okay, but on face cards, so how many do I have to pick from? Well, let's say for face cards, and they all have to be the same. So if they all have to be the same instead of just any face card, just use 1 C. Now remember, in poker, there's always usually a card that's wild, so that can count as a face card. So you're like, well, kings. Well, there's only 4 kings in the deck, but if 6s are wild, then those 6s could be kings. Okay, so that's 8. We want to be dealt 5. So there'd be 3 I wouldn't be dealt out there somewhere. Okay, now I don't know about you, but I'd rather number that down to, and then 3, 2, 1. Okay, 8 times 7 times 6 divided by 3 by 2 by 1. Okay, 56, but that would be just for kings. Well, there's queens and jacks too, so we multiply that by 3, or you could add 56, 56, 56. Okay, so that's 168. And then find the probability it happens. You divide your 168 by 2598960. Whoa, not very likely. Oh, I didn't times it by 100, my bad. Still not very likely, 0.006%, less than 100th of a chance. Okay, now I'm going to go back through here. At a fast food restaurant, you get your choice of 20 sandwiches. You get to pick one, so write 20 down. One salad, one side, you get to pick, there's 4 to pick from. It's like pick one and then out of this group to pick from. It's just a multiplication problem. And that's going to be 640, okay? In a 7-person competition, how many first through 7th place finish? Circle, underline those words. Those are very important, okay? So you have 7 people, so it's just the factorial, okay? So no, don't have to arrange much. 7 PRB. 5,040. Now, that needs to be labeled complete orders. Okay, there are 50 people in a free throw shooting contest. How many first through 4th place orders of finish are possible? Okay, so okay, there's some words, okay, but I got 50 people. So I use my question mark, 54 and 46. Now, here's the moment of truth, the $1 million question. Do you see words underlined first, fourth? You do. Protect that. So that means we're going with the permutation. We don't put that 4. You ain't allowed to touch that 4. He's bodyguarded, okay? So it's just 50 times 49 times 48 times 47 times 46. And that's just what I calculate. Okay, quite a few. 5,527,200. Now it's orders, but it's not complete orders. It's just orders first through 4th. Okay. 20 people in my class. I need to pick 4 students to go to a math bee. How many combinations of students could I pick? So again, you got 20, but some of them are irrelevant. Okay. So 20, picking 4, 16 left. Okay. Now, you don't see those words though, brother. Okay. You don't see those words. You don't protect nothing. So it's a combination. And if it's a combination, you take 4. Okay. So 20 times 19 times 18 times 17 times 16. So you really got to look for those words. That means that's protected, not seeing the words there like first, fourth, okay? Words like that. So it ain't protected, okay? 4 times 16. 4,485. Now, we don't even put orders on that. We put combos of 4. That's a lot of combinations of 4 people I can pick. All right, now a card problem. Oh, there's that question again. Probably 2,598,960. So I don't have to keep doing the C with the 52, the 5, and the 47. Okay. How many ways can I be dealt 5 hearts from a deck of cards? There are 13 hearts in the deck. So all I see is just one category, it's just C. And you're going 13, 5, and 8. Okay. So again, C's, nothing's protected. Okay, so 5, 4, 3, 2, 1. Okay. Divided by 5 by, whoops, sorry. 5 times 4 times 3 times 2 times 1. That ain't right. 13 times 12 times 11 times 10 times 9 divided by 5 times 4 times 3 times 2 times 1. Okay. 1,287 combos of 5. That's combinations of 5 hearts, though. Okay. Now to find what the probability, the percentage, put that in the numerator, that in the denominator. So divide times 100. 0.05%. Okay. Okay, now you have this page to do, and the back page is a card hand. You should have that answer down by now, just knowing it. All red cards, okay, you only use 1 C. Now some of you are like, well, when do we use 2 C's? That's if it gives you like 2 different types of cards, okay? But right now it's just red cards. It's one category of cards. So you use 1 C with the 26, the 5, and the 21, okay? And then calculate that C and go from there.